Hi, welcome to my next video on coordinate geometry. Today I'll be handling some questions that I saw over the years. Some of them are very similar to those I guessed it on past papers. A lot of them have accumulated from just students bringing questions to me. But I guarantee you all of these questions here today are challenging questions. And once you go through all of these questions, I think that you will be 99% ready for any question on coordinate geometry. So let's get started with the first questions. Over here, I'm going to call this question 1, right? Okay, now when you're watching these videos, if you click on details, you will see a table of contents. So you could basically fast forward to any one of these challenging questions. In fact, I'm going to call these questions, I'm going to label them with C and then 1 and then C2. The C is for challenging, right? So that's how I will label it in the details on the YouTube video itself. All right, so let's get started with the first question. Here we have two lines, two straight lines. One is black, one is red. Now here's what the examiner was asking, or the person, whoever came up with the question. These two lines currently are not touching. You notice there's a space between the lines. However, common sense would tell you that if this red line were to be a little bit longer, like if we were to make it longer, the two lines would meet at that point. There must be a point of intersection. This point of intersection must have an x coordinate, and guess what? It must have also a y coordinate. So in today's question, we're going to try to figure out how to get the point of intersection between two lines. Now, believe it or not, this is actually a Form 3 topic in disguise. Anytime you are trying to figure out where two lines meet, or two curves, or a line on a curve, and then we're trying to figure out where two graphs meet, it's really a simultaneous equation in disguise. All right. So guess what? To do this topic, you need to understand simultaneous equations. So I have a little thing here I'm going to try with you all. Now, this is really an AdMaths video. So by now, you should be able to do to solve a pair of simultaneous equations. Now, anytime you see the pause button up here, I want you to pause the video and try to do whatever part of the question is on the board at the moment, right? And then you can continue playing the video and see if you got the same answer as me. So right now, it's not on pause. When I want you to do a piece of calculation on your own, I will flip it over. All right, so here's what. When you are solving a simultaneous equation, you need two equations. Lucky for you, we have two equations here. So let's write back the two equations. Y is equal to 4x minus 1, and the second equation is 2y minus 5x minus 3. By the way, this was, I made a slight mistake, nothing too big. This was supposed to be an equal sign here. So put the equal sign there. Minor mistake. What we have to do is solve these pair of simultaneous equations. And from experience, whenever you solve a pair of simultaneous equations, you get two answers. Well, in this case here, you'll get one answer for x and one answer for y. Those answers will be the point of intersection of the two lines. So, there are many ways to solve a simultaneous equation. My personal favorite is the substitution method. It never fails me. So I want you to pause the video and see if you can solve these two simultaneous equations. So go ahead, solve it, and come back. All right, so it's my turn to solve the simultaneous equation. I'm going to use the substitution method. Over here in equation 1, you notice y is already the subject. So anywhere I see a y, I can throw it away and replace it with 4x minus 1. So I'm going to go to equation 2. I'm going to write back the whole of equation 2 here. I'm going to space it out a little bit. And you notice there is a y here. So I can throw this y away and replace it with 4x minus 1. And you notice I put it in brackets. I keep telling students, hey, anytime you're going to make a substitution, please put it in brackets. So let's go. Let's multiply this out. 2 by 4x is 8x. 2 by minus 2 is minus 2. I multiply both of them by 2. 5x equals to 3. Let's solve for x. Let's keep all the x's on one side, and the minus 2 doesn't have an x, so I throw it across on the other side. So I'm left with 8x minus 5x is equal to 3 plus 2. 8x minus 5x is 3x is equal to 5. The 3's are multiplied, throw it across, you get a divide. So my x value, right, I'm going to erase this 3 here because I threw it across on the other side. My x value is 5 on 3 or 1 on 2/3 or 1.66 reoccurring. So I have my x coordinate for the answer. So I'm going to make some space here. My x coordinate is 1 and 2/3. Okay? Right. Now it's time for me to figure out my y value. So to get my y value, I go back to the first equation. Notice y is already the subject. And I am going to replace x with the value I just got. Isn't this the x value? Now 1 and 2/3 is the same thing as 5 on 3. Let's multiply this out. Well, I'm going to use my calculator and my fractions button. I'm going to take 4 and multiply it by the fraction 5 on 3. 4, so I'm going to put it on first. 4 multiplied by 5 over, well, 5/3. And the answer I get, I'm going to minus 1. And when we work out this entire thing here, we get 5 and 2/3. So my y coordinate is 5 and 2/3. So when these two lines extend, they will meet at these two coordinates. The x and y coordinates here. Now that's a general thing I want you to remember for future questions. Anytime you're trying to figure out where two lines meet or any two graphs meet is really a simultaneous equation in disguise, and don't expect the examiner to remind you of that fact. You need to know that as an ad maths or even a maths student. All right, let's try another question, right? Challenging question number 2. All right, let's erase. I didn't have much energy this morning, but my wife bought me a coffee and I'm drinking it right now. So I'm getting some extra energy here today. All right, let's try with the other question. Right, C2. All right. So this one is actually there's a line here starting at A, which is 0, 4, and it's ending at point B, which is 10, 8. It's supposed to be a straight line. Sorry for the neat drawing. Now, apparently, there's another line here. And the line is at right angles. The green line is at right angles to the black line. And it cuts the black line exactly in half. So by now, if it cuts it exactly in half, you know the green line is a perpendicular bisector, which makes over here the midpoint. So we're going to be using the midpoint formula at some point in time. So I hope that you took notes from the last video. Now, apparently, this point, this green line, goes through the point C. And C has the coordinates K and 1. So the question wants you to find the value of K. Alright, so this is going to be tons of fun. All right. First things first, just a quick refresher. How do you find the midpoint? The midpoint of the line is x1 plus x2 divided by 2, and the y coordinate is y1 plus y2 divided by 2. Also, if I have a line and the gradient is 2/5, the gradient of any perpendicular line, meaning 90 degrees, to find the gradient, you have to flip the gradient of the first line, the line it's perpendicular to, and then you change the sign. So if it's positive, this will be negative. All right? So we're going to use these two things to help us find the value of k. First things first, let's find this midpoint here. I think it's a very good idea to find the midpoint. Please excuse me if I hustle it. You're going to add the two x coordinates, x1 and x2. 0 plus 10 is 5. 5, oh, I gave away the answer. Sorry, I did it too fast. 0 plus 10 is 10. 10 divided by 2 is 5. So the x coordinate of the midpoint is 5. Let's find the y coordinate of the midpoint. 4 plus 8 is 12. 12 divided by 2 is 6. Right? Cool. Now here's what I'm going to do. I am going to find the gradient of the black line. So, how do you find the gradient of a black line? Well, maybe of a black line, of any line, sorry. Is y2 minus y1 divided by x2 minus x1. So let's find the gradient of the black line. Let's put in y1 and y2. Let's find the gradient. It's going to be 8 minus 4 divided by 10 minus 0. Just double checking my work in here. 8 minus 4, 10 minus 0. I think on top we are going to get 4 divided by 10. Better note, this is a strange coincidence. 2/5. I swear I did not plan that. So the gradient of the black line is 2/5. All right. So the gradient of the black line is 2/5. So that means the gradient of the green line is minus 5 on 2. We flip it and change the sign. So how do we find the value of k? I mean, I made you find the midpoint. I made you find the gradient of the green line. What does this have to do with finding the value of k? Well, let's pay attention to the green line now. On the green line, I don't care about the black line anymore. The gradient of the green line is minus 5 on 2. So that means if I were to find the gradient of the green line using these 2 points, because these 2 points are on the green line, it will be equal to minus 5 on 2. So let's form an equation out of this. Let's call the first one x1 and y1. Call the next point x2 and y2. I am going to find the gradient of this green line using this formula. So let's find the gradient. Y2 minus y1, 1 minus 6, y2 minus y1 divided by x2 minus x1. And this is the value of my gradient. But I already figured out the gradient of the green line. The gradient of the green line is minus 5 on 2. So I'm going to put this expression equal to minus 5 on 2 and get an equation. And guess what? I'm going to cross multiply and solve for k, and that will be the end of my question. Alright, so I'm just double checking all my work in here. 8 minus 4, 4, 0, 10, 10. 8 minus 4, 10 minus 0 is 10. So it's 4 by 2/5, right? Everything seems to be correct so far. I don't seem to have any mistakes. Alright. Now I can simplify this before I cross multiply. 1 minus 6 is minus 5. So here's what I want you to do. Pause the video. work out the value of k and see if you got the same thing I did, right? So press the pause button and welcome back. Let's see if we got the same value for k. First of all, I always tell my students, whenever you have a fraction and a minus sign, it actually belongs to both the top and the underneath, right? Whenever it's smack in the middle. But to make the calculations easy, just pretend the minus sign is light, like it's very, very light, like a balloon, and let it float up to the top. So put it equal to the minus 5. So, and when you do that, then cross multiply. Doesn't matter which diagonal I multiply first, but I always like to do this one first. Let's do some calculations here. Minus 5 by 2 is minus 10. Minus 5, you are multiplying both of them by minus 5. K by minus 5 is minus 5k, and minus 5 by minus 5 is positive 25. You see, don't forget to multiply both of them by minus 5. Students have the habit of multiplying only one of them. Let's solve for k. You want k alone on one side, everyone else on the other side. Throw across positive 25, you get minus 25. Minus 10 minus 25 is minus 35 is equal to minus 5k. The minus 5 is touching the k, so it's a multiply. Throw it across, you get a divide. Therefore, k is equal to 35 divided by 5 is 7. Two negatives give you a positive. So the value of k in today's question is 7. Alright, so that's challenging question number 2. Let's try another challenging question. Just checking the time on. The time is only 17 minutes. I'm gonna try to do all the questions I have to do today in 45 minutes. Alright. Right, so challenging question at C2. Next one has to be C3. Alright, C3. Alright, whoa, this is going to be a tough one. Alright, I'm gonna put the diagram more to this side, so I'll have all here to do the work in. Can't remember where I got this question from, to be honest. Alright. Alright. That shape there on the board is a trapezium. Right. So these two lines are going to be parallel lines. So you already know where I'm going to be going with this. That parallel lines definitely have the same gradient. So that's going to become useful. This is going to be the point P, which is 4, 2. Q is going to be 16, 8. S is going to be AB. And R is going to be 5. I'm going to put it further. I have a good feeling I'm going to need space there. R is going to be 5 and 10. Now, anytime I see a question in AdMaths or Maths that has the letter S, please write very carefully, because it's so easy to mix up the 5 and the S when you're under stress in the exam. Right? I'm just going to make this a little more bendy here for a reason. Let me tell you what the purpose of this question is. These two lines do not touch, but if I were to extend this line PR and make it longer, and if I were to extend QS, they would eventually meet here at some point. I'm going to call that point T. But this only happens if you extend this line and extend that line. The aim of the question is to find the coordinates of T. And I'm going to call the coordinates of T just simply X and Y. So that's the aim of the question. So let me write this. I'm having trouble writing this point R here to make it look neat. Don't like when it doesn't look neat. 5 and 10. All right. So let me tell you how to go about this question. First of all, we need to find the equation of this line. Now, this line and this line, you see the black part and the dashed green line, they are basically the same line. So, this entire line has the same equation as this portion and as of this portion, right? So, once we find the equation of this line, it's automatically the equation of the entire line because this is just a part of the bigger line. Also, if we were to find the equation of from here to here, then once we find the equation from here to here, that would be the equation of the entire line. So what I'm building up is this. When we find the equation of this line and find the equation of this line, we are going to solve them simultaneously, because that is what simultaneous equations are used for. It's used to figure out where two lines meet. All right, so let's begin. Now, I'm going with the assumption that you know all the formulas by now, how to find the gradient of a line, how to find the length of a line, that parallel lines have the same gradient, and so forth. So, first things first, let's find the equation of whatever we can find first. So, let's find the equation of PQ. That seems to be the easiest thing. The more information we have, the better. So, how do you find the equation of PQ? Call here x1, y1, x2 and y2. Y is equal to mx plus c. Let's find the gradient first. Gradient is y2 minus y1 divided by x2 minus x1. Okay? Oh, here's what I want you to do. I want you to pause the video, see if you can find the equation of PQ from here to here, and then start back the video. Well, continue to watch the video and see if you get the same answer as me. So try that and welcome back. Let's try it here. Y2 minus y1. 8 minus 2 divided by x2 minus x1. 16 minus 4. That's 6 divided by 12. Hey, got a nice number. It's a half. All right, just double checking everything at 8 minus 2 and 16 minus, just double checking, right? So that means the gradient of this line, the line PQ, is a half. Let's find C. Remember, to find C, you just need 1 point on the line that we are considering. It's the line PQ. So choose either P or Q. Let's choose point P. Point P, since I have smaller numbers, y is 2 and x is 4. Replace y with 2 and x with 4. Please put your brackets. Half of 4 is 2. When you solve for C, you'll get 2 minus 2, which is 0. So C is 0. Right. So the equation of this line here, I'm going to use a red marker. I'm going to use something I can write really well. This line here, oh, this is a terrible marker. The equation of this line here is y is equal to a half x plus 0. You don't have to put the plus 0, but I'm just going to leave it. And in fact, I'm going to take it off. Right. So we have the equation of that line. Well, I think we should now try to find the equation of this line, of R to S. That's going to be super easy, because to find the equation of this line, how it's already parallel to this line, we know something about this line already. We know that the gradient of this line is automatically a half, because these two lines are parallel. So I don't need to work out the gradient of RS. So this is what I know about RS so far. RS is y is equal to mx plus c. I already know that your gradient is a half. Let's find C. To find C of this line, we need to choose a point on this line. Now I can choose R. I could choose S, but that's not really a good decision, because I don't have values for s. I don't have the x and I don't have the y. I have a good feeling that I'm going to be forced to find. Oh, by the way, the question also asks us to find the values of a and b. So I'm going to show you how to find that also. As well, find t. So to find c, let's choose the point r. According to the point r, x is 5, y is 10. Replace y with 10, replace x with 5, and solve for c. Alright, so solve, well, see if you can solve for c. And let's see if we get the same answer. Alright, so let's continue. We have a half multiplied by 5, that's easy. That's 2.5. Throw across the positive 2.5, you get minus 2.5. So C should be 7.5. Alright, so let's double checking everything here. Okay, so now we have the equation of P of RS. Now I'm going to write it over here so that you can see everything better. The equation of PQ, which was this line here, is y is equal to a half x. The equation of RS, we just found it. It's y is equal to a half x, and its y-intercept was positive 7.5. Okay? I just don't want my diagram getting too crowded. It's a really small diagram, and I really can't fit all the information onto it. Okay, so let's try to find the equation of QS. Now, if you notice that the gradient of this line is a half, so that means, well, you notice they put a right angle here. So this line and this line is at right angles or perpendicular, which means that the gradient of this line, we just have to take the half and flip it and change the sign. If it's positive, you will get a negative. Minus 2 divided by 1 is minus 2. So the gradient of this line is minus 2. Alright, let's find the equation of QS. How do you find the equation of QS? Once again, it's just y is equal to mx plus c. We know the gradient is how much? Minus 2. So we just need to find c. So to find c, we need to choose one point on this line. S is really not a good choice. Q has numbers. So go and replace y with 8 and x with what? 16. Let's solve for c. Minus 2 by 16 is minus 32. Throw across a negative, you get a positive. C is 40. So that means the equation of QS is y is equal to, the gradient is minus 2x, and the y-intercept is positive 40. Alright, so what we are going to do, we are going to find the coordinates of AB, and then we are going to find the coordinates of T. This is going to be rather easy. It's just going to boil down to simultaneous equations. If you want to figure out the coordinates of S, it's really the intersection of this line and the intersection of this line. So you want to figure out where these two lines meet. This one is RS. We have RS. This is RS here. And QS. We just have to solve these two equations simultaneously. So here's what I needed to do. Pause the video, solve the two simultaneous equations. You'll get x coordinate and a y coordinate. The x coordinate will be A, the y coordinate will be B. Right, so take a few seconds, come back, and let me know what you got. Welcome back, and let's see. Right, so we're going to solve them simultaneously. You notice that y is already the subject here and y is already the subject. I could throw away this y and put this over here. So you will get 2x plus 7.5 is equal to minus 2x plus what? 40. So I usually call this the YY method because y is already the subject here and y is already the subject here. So the two items after the y, I just put them equal to each other. I just put this here, and put an equal sign between the two expressions. Let's solve for x. Draw across all the x's on one side, all the non-x's on the other side. See what this looks like. Get a half x plus 2x is equal to 40 minus 7.5. A half x plus 2x is 2.5x, better known as 2.5x. Need a calculator here. 40 minus 7.5 is 32.5. Throw across the multiply, get a divide. 32.5 divided by 2.5 is 13. So that means A, the x value, is 13. Right, have a good feeling I'm going to have to make this brackets a little bit bigger when it's time to tell you B. Alright, to find B, we run back to any one of these two equations. Both of them will give us the same answer. Let's run back to QS. The values here look a little bit more friendly. We just figured out x was 13. Go over here, erase x, replace it with 13, work this out, it will give us the corresponding y value. Minus 26 plus 40. I got 14. I should have been able to do that in my head. So B is 14. 13, 14. Alright. So, next part of the question. We also want to find T. This is almost going to be a repeat of the question we just did, except two different equations will be used. We want to figure out where two graphs meet. Simultaneous equations again. We want, if we extend PR and QS, those two equations will meet at T. So we have to solve PR. Do we have equation PR as yet? Nope, we didn't find equation PR as yet. So let's find PR. Right? To find the equation of PR, we need to use points P and R. So let's find the gradient quickly. Y2, sorry, we'll call this X2, Y2. We're calling this one X1 and Y1, and this one X2 and Y2. So it's Y2 divided by X2 minus X1. 8 divided by 1, which is 8. Let's find C. Y is equal to mx plus C. We know m is 8. To find C, we choose 1 point on the line. I'm going to choose this one. Replace y with 2. Replace x with 4. Please put your brackets. 8 by 4 is 32 plus C. So, throw across the positive 32, you get minus 32. So that means C, sorry for the space here, is minus 30. So what's the equation of PR? Y is equal to 8x minus 30. Right, so we have the equation of PR now. Right, I hope I did everything correct there. Yep, looks about correct. So, to figure out the coordinates of T, we need to take the equation of PR, tick here, and the equation of QS, and we need to solve them simultaneously. We can use the YY method once again, right? Gonna put this equal to this because y is already the subject in both of them. So you get minus 2x plus 40 is equal to 8x minus 30. And we have to solve them simultaneously. Let's see how this goes. Throw all the x's on one side, everything out to x on the other side. minus 2x minus 8x is equal to minus 30 minus 40. That's correct? Yep. So you get minus 10x is equal to minus 70. Throw across the multiply to get divide. X will obviously be equal to 10. So the x coordinate of where these two graphs meet is x is equal to 7. Right? Okay. Let's find the corresponding y coordinate. Go to any one of these equations, doesn't matter. And you're going to replace x with 7. Let's go to this guy here. It looks easy enough. So we're going to say 8 by 7. 8 multiplied by 7 is 56 minus 30 is equal to 26. So this y value here is 26. And we are finished with the entire question. The coordinates of S is 13, 14. The coordinates of T, 7, 26. If this video was a little bit long and tedious, please rewind it and watch it again. Try it on your own first, right? You may get some things wrong. It's not a problem. But when you find that you're stuck, just continue. Just press play and continue to watch the video, right? There's nothing wrong with trying to work back a question you already worked out. It's practice. You're just trying it again. All right. All right. I'm gonna pause this video. I'm gonna call this video an end. And in my next video, I'm gonna work out 2 more questions. I'm gonna work out C4, challenging question number 4, and then challenging question number 5. I really need a water break at the moment. My throat is completely hoarse. All right, guys. So I guess I'll see you in 5 minutes. So take care and see you in a little while. Hi, and welcome to the next challenging coordinate geometry question that I have planned. All right, so let's jump straight into it. Let me explain what is required of this question. We have a triangle. The examiner has given us 3 points on the triangle. He then tells us that there's a perpendicular bisector of BC. Now, you all remember what a perpendicular bisector is? It's a line that cuts a line in exactly half, making this part equal to that part. And since it's a perpendicular bisector, it will cut the line also at right angles. So the red line is the perpendicular bisector of BC. Here's obviously the midpoint. Then he tells you AC also has a perpendicular bisector. Right. So it cuts the line AC at right angles. I drew the right angles here. And it cuts this line also in half. Obviously, if these 2 lines are extended, they will meet at a certain point. If the 2 perpendicular bisectors are extended, they want to know what are the coordinates of where the 2 perpendicular bisectors meet. So, since we're trying to figure out where 2 lines meet, it's really a simultaneous equation in disguise. So here's what I want you all to try. Of course, when I put this on the screen, you're going to pause the video and try it on your own first. I want you to try to find the equation of the red line and then find the equation of the green line, and then I want you to solve both equations simultaneously. All right, so get started. It shouldn't take you more than 15 minutes to find the 2 equations and solve them. So let me try now. Let's find the equation of the red line first. I'm going to do all the working for the red line in red. So the equation of the red line is y is equal to mx plus c. To find the gradient, it's y2 minus y1 divided by x2 minus x1. So y2 minus y1. So y2 minus y1 divided by x2 minus x1. Two negatives happen to touch. On top we get 0. 0 divided by 5. 0 divided by anything is 0. So we know our gradient of the red line, y is equal to 0x plus e. So the gradient is now 0. We still have to find c. To find c, we need 1 point on the line. Well, actually, we don't need to find c, but I'm just going to find it just in case. You'll see why c isn't important. To find c, we need to choose a point on the line. Let's choose point B. Y is minus 1. Sorry, I made a mistake there, sorry. Y is 1. X is minus 1 plus c. 0 by anything is 0, so c is equal to 1. Right. Now here's what I want to take away from this line. Okay? And this is a very, very important question. If the gradient of this line is 0, so the grade, I'll just drawing back BC here. It's going to run into a huge problem here. So the gradient of BC is 0. So the red line is at right angles. So whenever you want to find the gradient of a line at right angles, you flip this gradient and you have to change the sign. We all know 0 is the same thing as 0 divided by 1. So let's flip this and see what happens. We're going to get 1 divided by 0, and the positive becomes a negative. Well, 0 already doesn't have an opposite, but let's put a negative. 1 divided by 0 will give you an error on your calculator. So we have a little problem here. Okay? Which brings us to a piece of theory I need to introduce into this question. Something called, well, I just call it special graphs, special lines. Let's see. This is going to take a while, so be patient, but it's very, very important. Let's say I have a graph. And let's say here's 1, 2, 3. Let's do this quickly. 1, 2, minus 1, minus 2, minus 1, minus 2. If I ask you to find the gradient of a slanted line, you have a method. We've been doing it all the time. We find M and then we find what? C. However, there are some lines, whenever you are trying to find the equation of it, I would prefer if you do no working for it. The examiner won't even care to see working for it. Okay, as far as I know. If I have a perfectly horizontal line going through 2 on the y-axis, you see how this blue line is perfectly horizontal? The equation of this line is y is equal to 2. No working is necessary. Okay? Right. Let's try our next one. Let's say I had a horizontal line going through minus 1 on the y-axis. The equation of this line is y is equal to minus 1. No working required. Okay? Let's put back this minus 1 here. So, if we do the opposite now, if we have a vertical line going through 3 on the x-axis, the equation of this line is x is equal to 3. That's the equation of the line. Huh? There's no need to go and find m and find c. And if I have a vertical line going through minus 2 on the x-axis, the equation of this line is x is equal to minus 2. Now here's the thing. Perfectly horizontal lines and perfectly vertical lines obviously cross at 90 degrees. Also, a perfectly horizontal line has a gradient of 0. Remember, gradient really means slope. So if something has a slope of 0, that means it's perfectly flat, like this whiteboard here. That means a perfectly vertical line has the opposite gradient, which is infinity. When you got the error on your calculator, they really meant infinity. So, let me explain what's going to go on here, but I need to find the midpoint of this line here first. Let's find the midpoint and I'll show you what I mean. So, I'm going to keep this here for a while. To find the midpoint is super easy. You just add the two x coordinates and divide it by 2. I'm not going to write down this one. Let's do this in our heads. Minus 1 plus 4 is 3. 3 divided by 2 is 1.5 or 1.5. The y coordinate midpoint, 1 plus 1 is 2. 2 divided by 2 is 1. Great. So here's what we have. When we found the gradient of BC, remember when we were finding the gradient of BC, the gradient was 0. That suggests that BC is a perfectly horizontal line, which means the red line is actually a perfectly vertical line, making a 90 degrees. That means if we try to find the gradient of this line, we should get an error, which we did. So, what's the x coordinate here? The x coordinate is 1.5. This vertical line, if we were to draw it on graph paper, it will be a perfectly vertical line going through the line, going through 1.5 on the x axis. Okay? So, what would be the equation of the red line? The equation of the red line, a perfectly vertical line going through 3, is x equal to 3. A perfectly vertical line going through minus 2 on the x-axis is x is equal to minus 2. So what do you call a perfectly vertical line going through 1.5 on the x-axis? Simple. X is equal to 1.5. So the equation of the red line is x is equal to 1.5. So we know the equation of the red line. So I'm just going to, the red line is y is equal to, sorry, not y. The equation is x is equal to 1.5. X is equal to 1.5, sorry, I'm a little sleepy. All right, so x is equal to 1.5 is the equation of the red line. Let's find the equation of the green line. First of all, what's the gradient of AC? Whatever we get for the gradient of AC, we have to flip it and change the sign. Okay? So, let's find the gradient of BC. Well, gradient is y2 minus y1 divided by x2 minus x1. y2 minus y1, 1 minus 3 divided by 4 minus 0. You're going to get minus 2 divided by 4, which is minus a half. Which means that if the gradient of AC is minus a half, that means the gradient of the green line, which is at right angles, we have to flip the minus a half, so we'll get 2 on 1 and change the sign to positive. But 2 divided by 1 is 2 when you put back the positive sign. But you don't have to put the positive sign. So, the gradient of the green line is 2. But we need the equation of the green line. So we know the m is 2. We just need to find c for the green line. Remember, this is the midpoint. To find c, we need a point on the green line. This here is a perpendicular bisector. So let's find the midpoint of AC, and that shall give us a point on the green line. How do you find the midpoint? You add the two x coordinates divided by 2. 0 plus 4 is 4. 4 divided by 2 is 2. 3 plus 1 is 4. 4 divided by 2 is 2. So now we have a point to put in here. X is 2, y is 2. Y is 2, x is 2. I'm going to work upwards here. 2 by 2 is 4 plus c. Throw across positive 4, you get minus 4. So that means c is minus 2. So that means the equation of the green line is y is equal to 2x minus 2. Because remember, the gradient was 2. We got it here. And when we solve for c, we got minus 2. So I hope you got those two answers when you were trying to solve it. Or when I asked you to pause the video and get the equation of the two lines. Almost done, almost done. So we have to solve these two equations simultaneously to get this point here, the orange point, xy. This is going to be easier than you think. This simultaneous equation, the red one, has already been solved. X is equal to 1.5. So x is 1.5. To solve for y, we just have to go to the second equation and replace x with 1.5. 2 multiplied by 1.5 is 3. 3 minus 2 is 1. That's our y value. And that's this point here where the two graphs meet. I would really suggest that you rewind this video, pause the video, and try to work back the whole thing from scratch and see if you arrive at these two same answers. With these two answers, sorry. Alright, so we check the time on the. Let me check the time here. 14 minutes. Not bad, not bad. I have another question for you. Don't worry, I have another question. Another challenging question. Alright, that'll be C5, challenging question number 5. Alright. Now in this one, I'm going to be moving a little bit quicker. Right? Let's say I have two lines. Hope I draw them properly. The equation of this line is x plus y plus 2 is equal to 0. And I have an orange line. The orange line is coming like this. Boom. It's 3x minus 2y plus 1 is equal to 0. So they gave you the equation of both of those lines. Apparently, you see where these two lines meet? There's a line going through that point. And this blue line apparently is perpendicular to the green line, which is 3x plus 3 is equal to y. Alright. You know what they want you to do? They want you to find the equation of the blue line. So the aim of the question for the blue line, we have to find M and we also have to find C. This is going to be a long day. Okay. I have a small piece of theory that was introduced earlier into one of the videos. Well, I can't remember when I told you, but I'm going to go through it anyway again. Alright, give me a few seconds here. The equation of a line, like if I told you the equation of a line is y is equal to 3x minus 5. And I ask you, hey, Mr. Line, what is your gradient? You would tell me the gradient is 3 because the number touching x is 3. And if I ask you how much is the y-intercept, you would say the y-intercept is minus 5. Because you know the general form is y is equal to mx plus c. So let's change this up a little bit. If I had the line y 4y minus 8x is equal to 10. Let's make the 10. And I ask you, how much is the gradient? A lot of people would say, well, like in this one, the number touching x is 3. So they would say the number touching x here is minus 8. So your gradient is minus 8. And the number without any x's attached to it would be c. This would be completely wrong. To figure out m and c, y must be the subject. You can't say the number touching x is gradient and the number without x is the y-intercept. unless y is the subject. But it brings me back to this question. Is y the subject? No. 4y minus 8x. For this to be the subject, y alone has to be on one side and everyone else has to be on the other side. So before I can tell you how much is m and c, I have a little bit of rearranging or transposing to do. So I'm going to throw across minus 8x to get positive 8x. And then the 4 is a multiply. So when I throw it across, I'm going to get a divide. So it's going to look like this now. Y is equal to 10 plus 8x divided by 4. But here's what. The x in the first example, the x was completely separate from the non-x. Here, everything on top is being held hostage by the 4. But you know, this really means everybody on top gets divided by 4. So let's just separate them one time. You get 10 divided by 4 plus 8x divided by 4, which gives us 10 divided by 4 is 2.5, 8 divided by 4 is 2, and don't forget to put back the x. Right. Please write this down, because I have to erase this now. I'm going to erase this. So when we simplify that whole thing, we got this. Sorry for the little space here. Y is equal to 2.5 plus 2x. I just wrote it back closer. Now, because y is the subject, I can identify m and c. So, m doesn't necessarily have to come first. M could come second. The rule is, once y is the subject, the number touching x is your gradient, or m. So, my gradient is positive 2 or 2. And my y-intercept is the number without the x. So, my y-intercept is 2.5. Right? So, I just letting you know that we're going to apply this to over here. And the reason I'm telling you this, you can see this over here, if I ask you what's the gradient of this line, you can't tell me unless you make y the subject. And over here, you can't tell me the gradient of the line unless y is the subject. Alright? Okay, now looking back at the question, I have a good feeling we're not going to need this, but that's okay. I needed to show it anyway. Alright? Let's go ahead anyway. It doesn't matter. We learned something new. Right? So, let's get started with this question. Okay, first things first. We need to figure out where these two graphs meet. That's going to be key in the question, right? I can't imagine the examiner giving us this and then not asking us to find where the two of them meet. So I'm going to find out where these two graphs meet, because it could be useful in the question. So if I want to figure out where these two graphs meet, you know it's going to be a simultaneous equation. Equation 1, equation 2. Pause the video, work out the values of x and y. That's where these two graphs meet. Where the black one and the orange one. It also happens to meet the blue graph. But solve it and see what two answers you get. Alright, welcome back. And let me solve it and let me see what I get. S plus y plus 2 equal to 0. You have no idea how much I dislike solving simultaneous equations. No way, it's like a chore. No way. Alright, so here's what I'm going to do. This is equation 1, this is equation 2. I am going to make x the subject and then substitute it inside here. So to make x the subject, I have to throw across positive y and positive 2. That will give me x is equal to minus y minus 2. And this is my equation 3. I'm going to substitute this into equation 2. So let me get the, well, I'll use red. 3. I'm just going to pause space here and put that in after. 2y plus 1 is equal to 0. Remember, I'm replacing this x here with minus y minus 2, and I'm going to put it in brackets. Alright, let's multiply the brackets and solve for y. minus 3y minus 6, multiply both of them by 3. This is this minus 2y plus 1 equal to 0. Running out of space. Minus 3y minus 2y is minus 5y. Right? And minus 6 plus 1 is minus 5 is equal to 0. Throw across the minus 5, you are going to get positive 5. Between here and here, there's a multiply. Throw it across, get a divide. Y is equal to minus 1. So I hope you got y as minus 1. So where these two graphs meet, so far, we know the y coordinate is minus 1. We just have to find the x coordinate now. To find the x coordinate, go back to equation 3. Wherever you see a y, and it have 1 here, erase the y and replace it with the value you just got. But please put it in brackets. So let's solve for x here. 2 negatives make a positive, minus 2. So x is 1 minus 2, which is an x minus 1. Pure coincidence. So the x coordinate here is also minus 1. Alright, so we're getting there, Right? So the aim is to find the equation of the blue line. So here's what. For the blue line, it should be really easy to find the gradient. We have the green line here, right? If we were to find the gradient of the green line, we just have to flip it and change the sign to get the gradient of the blue line, because both of them are perpendicular. So this is why I showed you the piece of theory just now, and then I realized it was useless, right? For this, it's useless for this particular question only. Remember, the equation was 3x plus 3 is equal to y. I didn't watch it properly, right? To be honest. If I watch this properly, I could just put the y on this side. I could just do a little switch around. Y is equal to 3x plus 3. If x is equal to 2, that's the same thing as 2 equal to x. You can just switch it around. But when you switch it around, you notice y is already the subject, and the x is separate from the non-x's. So if I ask you what's the gradient of this line, the green line, you can just simply tell me the gradient is 3. And the y-intercept, which I don't need, is 3. Both of them happen to be 3. So y was already the subject. So the gradient of this line is 3. So if the gradient is 3, then the gradient of the blue line, number 3 is the same thing as 3 on 1. You have to flip it. You will get 1 on 3, and the positive will become negative. So that means the gradient of the blue line, we now know, is minus 1/3. We just need to find C now. To find C, we need a point on the blue line. Minus 1 is on the orange line and the black line, because that's where the both of them meet. But it's also on the blue line. So we have a point to substitute in. Replace y with minus 1 and replace x with minus 1. And we will solve for C, and that will be the end of our final challenge question. So y is equal to minus 1/3 x plus c. Y is minus 1. X is also minus 1. Sorry, minus 1. And make sure for your brackets. You get positive 1/3 here. Throw across this. Minus 1 minus 1/3 is equal to c. Minus 1 and your minus our next 1/3. That will give us minus 1 and 1/3. Therefore, c is minus 1 and 1/3. You can't have a positive touching a negative. Simplify it to a negative. Because when a positive touches a negative, you get a negative. Alright guys, so that is my final challenge question on coordinate geometry. Alright, of course, if you come across a really challenging coordinate geometry question that's fit for the CXC syllabus, or the CXC syllabus, please feel free there's a number of ways you can email, get in contact with me. If you're from Trinidad and Tobago, you can WhatsApp me on 712-2652. You can probably email a question to me, a really challenging question. Of course, if I find it really challenging, I really don't mind making a video on it. And of course, I will attach it to this section of the website. Okay, I would prefer WhatsApping. I'm not really a big fan of talking on the phone. Of course, if you want to email me, you can always email me at iLoveLessons@gmail.com. Right? And of course, if you ever if you want to find out more about my lessons and classes, you can also visit www.iLoveLessons, don't forget this S there.com. Alright guys, so please don't forget to subscribe to the YouTube channel, and don't forget to share, like, and leave comments. Have a good day.